Hello, everybody, and thank you for joining us today. Welcome to day 2 of OSLC Fest 2020. This is the best event to learn who is doing what with OSLC. We had some very interesting conversations yesterday, and we will continue with more today. I would encourage you to join the OSLC forum and the OSLC Slack channel to participate in the broader OSLC community. The links are in the description field of this live stream. This is the second day of a 3-day virtual conference with 6 or 7 talks each day. We will have a total of around 20 talks, including 8 talks from software vendors explaining how they support and use OSLC. For more information on this year's event, you can go to oslcfest.org. You'll see the schedule of events there for today and tomorrow. My name is Jim Amsden. I will be your moderator today. I will do my best to stick with our time schedule and not let any of the sessions overrun too much. We invite the audience to participate by submitting questions to the speakers at meet.ps/OSLCFest. You can find the link to the meeting Pulse app in the description of the YouTube live stream. To ask any questions, you simply click on the Q&A button in the bottom left, and then on the Submit Question button. You can type your question and click Submit. You can vote questions up if you find them interesting, and we'll try to address the most popular ones at the end of each talk. But if we run out of time, which we are likely to do, the questions and answers will be posted on the OSLC Slack channel under the general topic. Also, please be sure to use the hashtag #OSLCFest, which is displayed at the top left of your screen when sharing OSLC Fest content on social media. Before we start, I'd like to thank Axel Reichman, Andrew Berezovsky, Jad Al-Khoury, Nick Crossley, Gabriel Fernandez. They all helped a lot in preparing for this event. Andrew will be your moderator tomorrow. Yesterday, our keynote speaker, Juan Sequeda, shared with us the history of knowledge graphs and how they enable the capturing, communicating, reasoning about, and acting on shared data. Jad then provided a survey of how OSLC is being used to facilitate tool integration for enabling federated access to shared data. We then saw presentations from a number of vendors, including IBM, PTC, Spark Systems, Sodius Wellert, that showed demos of how these integrations work for PLM, enterprise architecture, and ALM solutions. Today, we will take a little deeper dive into OSLC specifications and some of the open source technologies that support the development and integration of these tools. A quick reminder before we start, please submit your questions on the Meeting Pulse app. The URI for this app is in the description field of the stream. We appreciate your participation. For our first talk today, Andrew and I, as co-chairs of the Oasis OSLC Open Project, will provide a status update on the Oasis standards, OSLC standards, and open project activities. We'll cover the open project structure and its advantages over the previous Oasis Technical Committee structure. Next, we'll discuss the current status of the OSLC specifications and what we are focusing on, working on now. And finally, we'll send out a heartfelt request for contribution in order to further the value of integration. Take it away, Andrew.
Thank you, Jim. Hello, everyone, and welcome. I'll start with the description of open project, and probably the best way to start would be to describe how did we get here and why did we even decide to do the migration. So the discussion started last OSLC Fest in 2018, and a lot of people were excited to contribute, or at least to get more hands-on participation with the OSLC member section. But at the time, you were required to sign various CLAs, even to join the mailing list, and you had to pay your dues, even if you just wanted to join the calls, but not to have a lot of influence on the project. And when Oasis contacted us with their suggestion for a brand new Oasis Open Project Initiative, we jumped at this opportunity, and we migrated the member section to an open project. Steering committee didn't change that much. It was renamed into Project Governing Board and changed its members. KDH and IBM are co-chairing the board as of now. We also have a technical steering committee that we have not grown to need. But the most interesting part for you as contributors is that first, you don't have any legal obligations as long as your participation is very cursory and limited. So you can join the mailing list, you can join the calls, and you don't need to sign anything. If you want to contribute some content on GitHub, change the spec text, contribute the code, you will have to sign the CLAs, but you can do that without paying the dues. And only if you want to join the PGB and have a more direct control over the future of OSLC, you would need to become an Oasis member. We do have a weekly call. We dispersed with multiple TCs. So join us on Thursdays, 10 a.m. Eastern, 4 o'clock European. But some of you may be asking, why did we make this move? Are we just beating the dead horse, so to speak? So the move took quite an effort. It was a good effort because we were not doing that much hands-on work in the repositories. So we dusted off our practices. Also, we were one of the first Oasis projects to do the migration. So there were some rough edges in the process, which took some extra time. But then once we've gained speed, we released the first 3 drafts of the specs, which is quite a good result for the OSLC project in any given year. And we're expecting more drafts and spec releases this year. As a bonus, we went through almost all drafts that were released ever by the member section or the previous open services project, and we've cataloged them on the website. So now we'll go and take a look at what's next for OSLC. This is when we want to get your participation and to hear from you. So go to OSLC Fest. And as we speak, I just started a new poll where we would like to hear from you. Which specs do you think that are most relevant and most awaited from you this year? I'll go with the presentation, and then once I'm done, I'll close the poll and we'll take a look how our plans match with your expectations. So the key item for this year is the candidate Oasis standard of the OSLC Core 3.0 spec. Just as a refresher, this spec goes through the following stages: working draft, project spec draft, project spec, candidate Oasis standard, and then finally Oasis standard. And candidate Oasis standard is where basically things are out of our hands, and it's up to Oasis and members to vote and promote it to the Oasis standard. We're also actively looking for new contributors. We are quite well represented in terms of vendors, SMEs, and academia, and we're particularly looking for large OSLC users to join the community, to review the specs, to provide critical feedback and influence. But of course, if you're a vendor, SME, or academia, the merrier, the more the merrier. We also focused in our specs on more non-normative client guidance, which is strictly speaking not necessary, but we found that differences in implementation have created certain corner cases and caused some head scratching, and we just tried to make it as user-friendly as possible. We're also focusing on promoting other specs higher through their status. and I'll talk about this in future slides. So the key features of Core 3.0 spec are the following. We have harmonized the spec with the W3C link data platform, one of the key specs for building link data APIs. It's the same spec endorsed by Tim Berners-Lee and used in Solid. Ruben tomorrow will talk more about Solid and the Solid community. OpenID authentication was also added with some extra features that should make authentication in OSLC servers and clients a little bit less of a head scratcher. We've also defined attachment support, which has been added to some OSLC servers before, but now it's going to be a standard, and it will reduce the chances for incompatibility. Probably the most interesting part for vendors and users of OSLC today is that we decided not to introduce any breaking changes in Core 3.0. You can consider, strictly speaking, a breaking change that we decided to remove a must requirement from RDF XML. But we did this to enable OSLC compliant clients and servers to be developed virtually using any programming languages. So if your programming language library for RDF supports only RDF serializations such as Turtle, JSON-LD, or even bare bones and triples, we wanted to ensure that you're able to provide an OSLC compliant server. We're having final discussions on a bit more features, such as migrating the root service specs from Jazz as they became de facto standard, and submitting an INI application for a well-known URI that would make discovery even more seamless. But we're inclined towards feature freeze. So if you wish to see those features, you should voice your opinion very quickly. OSLC Query similarly did not introduce any breaking changes. If you have parsers for OSLC Query 2.0, they will still work on 3.0. And the spec mainly clarifies aspects that cause confusion and provide a lot of examples. The TRS specification also addresses on the aspects that cause confusion and specifying the corner cases a little bit better and providing some extra guidance for TRS clients, which was missing from the previous specs, to make the implementations more efficient and compatible. The ILDB spec draft that is obsolete has been merged into the TRS specification, and some parts of it are expected to be in the 3.0 spec. We have other exciting features, such as push-based approaches, where change events are pushed to consumers through Kafka, WebSocket, MQTT, and others. But we decided to deliver the spec as soon as possible, so it's in a feature freeze. If you wish to see those features, get in touch with us, and if you're ready to be an editor of that part of the spec section, the process will move faster. Finally, the last spec I want to talk about is the configuration management. It's a spec that actually has never been formally published, even in the old communities. So the project specification draft is on the way as we speak. And even though it's a draft, we do have a commitment not to introduce any breaking changes in the 1.0 version of the spec, because despite being a draft, it actually has been implemented in the field and used in many production environments today. So this is the update and the discussion of the future. I again encourage you to join our calls or GitHub repo. I'll close the poll right now, and we'll see what do you think. There is also a brainstorming tab on Meeting Pulse to the left of the Q&A that you can use throughout this whole 2-hour session today to submit your ideas where this OSLC open project should go. Okay.
Thank you, Andrew. I'd just like to add that the OSLC specification work at Oasis is actually quite a lot of work, covering a large number of different document specifications. Most Oasis specifications are dealing with single documents or small multi-part documents. We are dealing with roughly, nearly 20 different specifications make up the OSLC suite. And the domain specifications are specific to particular areas like requirements change, quality management, architecture management, and maybe even PLM domains and so on. We are a small team of dedicated people, but moving OSLC forward, I think will depend upon additional contribution from those of you out in the audience who have an interest and would like to contribute. We would sure encourage you to join us and participate. We'll have plenty of work for you to do. So I thank you ahead of time for your participation and hope to see you soon. Okay, so we're on schedule today, maybe even a little ahead. Dr. Jad Al-Kahori will join us again today for the next 2 talks. Oh, sorry, the questions, yes.
Before we jump to questions, on the screen, you can see the specs. The votes are in, the specs that people were most expecting. So Core 3.0 is, as expected, the most awaited spec. Domain specs are the close second, together with TRS, and config management and query specs have over 50% of attendees waiting for them. Let's jump to the questions.
Okay, the first question, is there a date for the releases of these specs? Well, we've had a target to release a lot of these specs for the last 4 years. So we would like to get the core spec to at least candidate Oasis spec in the next, in this half of this year, if at all possible. We think we are pretty close to ready to do that. Some of the domain specifications, change management, or requirements management should be able to follow along quickly after that. Some of the other specs, architecture management, really needs some additional work, especially as we look at how it fits in with the SysML v2 work that's ongoing at OMG. So I can't give you a definitive date when these will be candidate Oasis standards, but I would suggest that if you are interested, your participation will help accelerate the completion of these specs. All right, so for our next, any further questions came in? I don't see any. All right, so Dr. Jad Al-Kahori will join us again today for the next 2 talks. Jad is a researcher at the Royal Institute of Technology, KTH. He also runs a consultancy firm on tool integration. Jad has been very involved in OSLC efforts since the early days, and he is one of the leading contributors to Eclipse Leo open source project. Today, Jad will give us an update on the status of Eclipse Leo project, and then follow that with in his second talk with an introduction to Eclipse Leo Designer, which is a model-based generative approach to developing an integrated OSLC tool chain. For a quick reminder, please submit your questions on the Meeting Pulse app. You'll see the URL in the description field of this stream. We appreciate your participation, and we'll try to answer the questions at the end of the talk. Okay, Jad, I see your screen. You're ready to go.
Yeah, thanks, Jim. And I guess you can hear me also?
I can, yes.
Yeah. Okay, that's good. Okay, thanks for the introduction, Jim. My plan is to present Leo, and I wasn't planning to present updates on it. I'm assuming you're new or interested in the project, so my plan was to present the main features of Leo. It will be quite a technical discussion where I'll give you some pointers on what you can do with the Leo project as a developer for OSLC solutions. It will only be pointers, so I hope it's good enough for you to be, interested further, so you can look deeper into the actual project and its what it offers. This is also a call for contributions, so I hope you can make the project interesting enough so that you feel you can also contribute to the Eclipse open source project. Okay, so what is Eclipse Leo? It's actually an Eclipse project. The aim of the project is to help you quickly develop OSLC compliant solutions. It's targeting Java developers, and that's natural given that it's an Eclipse project, but that's really what the choice that we had to make, which language to choose. So it's really focused on Java developers. Leo relies on the Eclipse foundations, sort of organization, governance, the hosting, or the repositories, but we're not really just, there's a bit of a misunderstanding sometimes that you have to use Eclipse if you're going to develop with the Leo libraries, and that's not necessarily true. With Leo, we produce Maven artifacts, so as long as you develop with Java, you should be able to use the Leo libraries and SDKs. When it comes to licensing, it's open source. It's under the EPL license, so it's quite a commercial-friendly license, and that's sort of a conscious choice to make, because we really want to be able to make you use Leo for commercial products as well. Okay, a quick overview of what Leo offers in the big picture, and my aim is this is sort of the agenda for the coming 40 minutes. I'll dive deeply in each of these boxes. At the core of Leo is the OSLC for J SDK. That's like the software development kit, and that's really the set of classes, the Java libraries that really reflect the standard. And I'll go a little bit deeper into it, but that's all you really need to develop an OSLC compliant interface for your applications. On top of that, we develop some libraries, Leo Store, Leo Validation. They're not necessarily to reflect the standard itself, but they're really sort of common things we always felt we need. If you want to develop an adapter or a server, a Leo server, you needed these tools. So we sort of package them into libraries that you can add when you want to develop an adapter. And finally, on top, we have an application for the sort of the architect or the modeler, where you can graphically model and specify how your solution is going to look like. So it's sort of two components, and they're quite well integrated. First, you can specify, and then you can also generate code based on these libraries and the SDK. So it sort of sits on top of the libraries and this SDK to even make it even easier to develop Leo projects. Together with this, we have lots of reference implementations, samples, tutorials, documentations. That's really part of the Leo project also. I won't have time to give you all these pointers to all this information, so I will focus only on the blue part today. Leo is, sort of an open source project, so it's really, whatever the community wants to make out of it, that's what it becomes. So at the moment, I'm focusing a lot on Leo Designer and sort of the libraries, maintaining the core part as well, and together with Andre and Jim. But there's a lot to do when it comes to reference implementations, updating documentations, etc. And it's really quite a lot of content here to keep up to date. So there's varying degrees of maturities and sort of up to date with this project. Okay, so let's go a little bit deeper. When it comes to the core library, what do you get out of that? That's really the core part of Leo. That's where it all started. And these are the building blocks that lets you build your servers and your clients. And it makes sure that whatever you build is compliant with the standard. I will go even further details. But just in the general picture, OSLC is based on the REST architecture. So we're relying on the JAX-RS 2.0 specification, the Java specification for REST, to develop our servers. Previously, we used to depend on Apache Wink, which is JAX-RS 1.0, and that was a specific implementation of JAX-RS. We've actually recently removed that dependency, so now we're only dependency on the specification, which lets you use any implementation of JAX-RS, Jersey, REST Easy, whatever, to implement your own implementation. So that's a big lift for Leo, which we've done recently. To implement the RDF aspects, we're using Apache Geno. These are the main dependencies, external dependencies of Leo. Okay, so what do you get out of Eclipse Leo in the core? OSLC for J core. This is sort of the set of classes that reflect the standard. So if you use those classes, you're going to guarantee that you're following the standard in a certain way. These are classes that reflect things like service provider catalog, service provider, creation, dialogues, etc. And this is from the docs, just to give you an example. Oops, you can't see this. This says service provider. And there you can see you have the methods and the attributes where you can add a service, you can get the title, you can set the title. So that's the kind of easy way for a Java developer to create a service provider catalog or a error or a dialogue, etc. So it makes you construct your server relatively easy. What you can also get is we have annotations. So you can also annotate your operations, your REST services, specific with OSLC annotations, and that's a way to indicate to the library that these are my OSLC services, these are my capabilities, whether it's a selection dialogue or a query capability. And with these annotations, the library will read through them and give you the discovery capabilities that you can offer for the client. As an example, this is a REST application. That's just a Java class called an OSLC web service. And you can decorate it with just the annotation OSLC service, and then you can tell it what domain it belongs to. And when you start your application, the system is going to recognize that, okay, this is a service, it belongs to this service provider, which belongs to that service provider catalog. And then that provides the web services for you. I will show you in the demo how that works. You can also, for example, annotate your query method. That's the one that receives from the client the query request. You tell it, okay, this is a query capability. It's got this title. This is the resource shapes it provides. These are the resource types it returns, etc. These are your REST paths, etc. And then that becomes part of that service, OSLC service, etc. This is an annotation for Creation Factory. So just by decorating your REST services and the operations, you're going to get the whole hierarchy of the OSLC service provider catalog, service provider services, etc. A third feature of the core is the annotations on the actual Java POJOs. So if you want to define a class, let's say requirement, and requirement will have a property called identifier, you will annotate the requirement with, OSLC name, etc. Then you give it a name, the resource shape it belongs to, what does it describe, etc. And then for every property, you tell it what the, if you recognize this, OSLC occurs, whether it's exactly one, what cardinality does it have, what type of a property it is, whether it's read-only or not. And these annotations are going to be used when you want to translate your requirement instance of the requirement class to RDF. And I'll show you an example of that also. So this is how you decorate that. So with this information, we also have another component, which is the YAX-RS provider. And that's the one that can easily let you publish the information you want without having to deal with the GINA, with the RDF, with the linked data. For example, what I just showed you before, this is an operation I have, get requirement. That's what the user will request on this particular path to get a particular requirement. And as you can see in this method, all you have to do with Leo is just to construct your requirement instance, and that's the requirement class I showed you earlier, and then you just return the requirement. Now this operation will be captured by a YAX-RS provider, which is a writer, and will be able to translate this instance of the class requirement into the desired annotation, whether it's JSON LD or Turtle. And here is an example of what you can see. If that's RDF XML, I guess. So you don't have to do any as a developer. All you have to do is just annotate your resource class requirement with the right annotations, and then tell it what to produce. And then the library will take care of the translation from Java object down to the right RDF format you want. Same as the reading. If you want to create a requirement, you will do a post of a requirement using this format. But as a developer, you will actually receive an instance of the requirement class, and then you can deal with it just like any other Java object. So as a developer, I never really need to deal with the linked data stuff. I just work with Java objects. I work with YAX-RS services. That's the level we work at with Leo. Client is another library, and that's really to make it easy to work with a server. So you can create an OSLC client. You can look up a service provider catalog or a service provider. You can say, okay, give me a query capability, and then you can send parameters on, a title or to what kind of objects it wants to work with, and then you will get back a query capability, and then you can work further with that. It makes it easier to develop a query. Queries itself, there's a library where, if you recognize OSLC queries, that could be quite cumbersome to decipher these things. So if you receive such a string, you can just sort of to this library, you can parse it, and then you will get the children, and then you can sort of deal with the different parts of this one. That's all it does. What we've done, for example, in another library is you can actually take this, you can translate this query into a Sparkle query. So if you connect it somehow to a triple store, we can go all the way to from a query capability to from a query string down to a Sparkle query, so you can get your information out of the database. So I hope this is just giving you enough pointers. I'm not going to go much more further than that. Right, I have 4 minutes. Okay. Okay, so this is the core. I will just go through 3 libraries now that build on this. That's the core is all you need really, but Leo Store is another feature. We felt like if you want to develop with linked data, sometimes you want to store your resources in a triple store, and we wanted to build a library that makes it easier for you to work with a triple store. So Leo Store is really a way to make persistent your OSLC, your Java resources, instances. Think of it as an object relational mapping, like a Hibernate when it comes to SQL databases. Here, for example, I can do store.get resources. So given a particular triple store, I can say, give me all the requirements that fulfill a certain query. And all I get back, what I get back from this simple call is a list of my requirements. Again, that thing will translate from this down to a Sparkle query, gives me back the graph, translates it into a set of requirements or a list of requirements. I can also do store. Okay, here is a resource I have, just save it into my store, and that will save it for you. And then you can do a get on that, and then you get it back. So really, again, you work at the level of instances of Java and never have to deal with the linked data aspects. One scenario of the Leo store is to be able to sort of cache information. So let me explain this. Here is your tool server. Typically, you receive the REST requests. The server will have to talk to the backend tool, whether it's Jira or some tool of your own. As an example was Jira. So when you do give me a particular resource, you have to talk to the backend, get the information back, and then send it back to the client. With Leo Store, what we can do sometimes is, the actual tool itself can push this information to the store. So every time the data is updated in the store, you push it down to Leo Store. So you've sort of pre-prepared it, ready to be accessible to any client. So then when the client says, give me this particular resource, if the resource is in the Leo Store, you never have to talk to the backend tool to actually give the response. And the response is already pre-prepared according to according to OSLC. So you just send it back. So it removes the load on the engineering tool, the backend tool, to respond. Everything is cached here, and this is all prepared beforehand. That's one scenario that we use it with. I have a scenario where I have a lot of JSON files here, where I don't want to do a parsing of the JSON file every time I make a request. So I prepare all the JSON down into a store, and then this server never needs to talk directly to the backend tool every time it gets a request. Leo validation is a library where we use the annotations to decide whether you fulfilled. When you create a requirement, you have the annotations that tell you what type of properties you have, their cardinality, etc. With this simple call, you can make sure as a developer that your actual instance is already full with all the information you have. This could be valid if you're doing a requirement. Someone is posting you a requirement. You want to make sure that that object that you've received is valid according to the resource shape you have. So you can get a validation, you get a report, and then you can decide whether it's valid or not. This is quite an early, premature thing. So here, there's always room for contributions, of course, if you think such a feature is important and you think you can help. TRS server, Andre just mentioned TRS. I'm not sure if everyone's familiar with it, but that's really a way for the server to, clients can register to a server and say, okay, I want to get updates of the log. Anything that happens with this set of resources of the server, I want to be notified, whether something gets updated or created, etc. We've recently developed a library that makes it very easy for you to provide that kind of feature of a TRS. The current implementation is a prototype, so the actual TRS log that the client can query is in memory. So it's not really sort of production ready. Once you restart the server, you've lost your logs. But we really want to work on a next phase where this thing, the actual log, is saved on persistent, so that every time you restart your server, you can continue where you left. And that's really the level you work on. Again, you work with objects and you say, okay, if this object is created, then I register this event that says, now I've created this object, or now I've modified it. And the library takes care of all the web requests to handle client requests from the TRS server. How am I doing on time, Jim? I have a feeling I'm done.
You're doing fine, Jad. Keep going. You still have 5 minutes.
Okay, excellent. So I think what I'll do now is, this is a very quick introduction to the core. In 20 minutes, I wanted to sort of talk about Leo Designer, which is a way of not even having to write code, like minimizing that and give you an easier way to specify how you model. Because really, if you think of Leo, what I've showed you now, it's really for the developer when you're implementing a particular server or a client. This is makes it very easy to write the code with all the annotations and all the services you get. But you need to do a lot of work beforehand before you get there. For example, if you're doing a tool chain where you have, like, especially for in-house kind of tooling, where you have multiple tools you want to connect, you really want to get the big picture of what are my tools, which tool earns which data, which one is consuming from which tool, etc. So there's kind of you want to get an overview of your toolchain architecture in mind before you start implementing. Definitely, if you're not using the standard OSLC domains, you might want to do some information modeling. What are my artifacts? What are my OSLC resources that I want to share? What are their attributes? What are their cardinality, etc. So you want to sort of specify, and typically that's done in a class diagram or on paper or on the whiteboard. OSLC has a special way of defining these resources, and you might want to get more concrete support instead of just a class diagram. You want to get an OSLC way of defining your information model. And once you have your implementation, you want to define what services to provide, etc. For each tool. So you really want to be able to specify that, and only until then can you give it to the developer and say, okay, implement this. And you really want to make sure developers develop it according to the OSLC standard. So for that, what we did is develop an application that lets you define this. It lets you specify the information model for OSLC resources. This is only relevant if you're not using the standard domains, because they're already available for you with Leo, the reference sort of implementations of the resources. But if you have your own modifications of that, we give you the possibility to model according to the OSLC standard. You can have an overview of your classes, your servers and clients. And then also you can go even one level down and say, okay, which services am I providing for which server? What am I consuming, etc. And that becomes a specification. And that would be good enough overview of your, like, an architecture, and then only then can you develop it. But not only that, once you have that, there will be enough information so that you can automatically generate each of these adapters. OSLC has a lot of guidelines. It's quite repetitive, all this with the REST and how you define resources and stuff. So if you have enough information in the model, and I'm talking model-based development here, then you can generate pretty much all of your code for an adapter. Let's say the skeleton, and then you just have to, of course, add some, tool-specific kind of code to make it work all the way. But we think that if you have enough information in the specification, if we follow the best practices and the guidelines in the OSLC, you can repeat the same patterns on every server, and then the developer will have to develop a small amount of the actual implementation, but the most important part, of course. So I will stop here, and actually I will spend the second 20 minutes just to show you, and there's no point really, maybe I'll do a demo of Leo Designer instead to show you what I meant by this and what kind of capabilities you can get out of this Leo Designer. You can think of it as a big wizard that gets you started with, so you don't have to write so much code. It gives you the code sort of skeleton out of the box when you're modeling it. So that's it, what I had for these 20 minutes, Jim.
Jed, we have a few questions.
Yes.
Let's see. There seems to be some interest in other languages besides Java. What about JavaScript, Python, Swift, C#, things like that? Any comment on that?
I mean, the only comment that I'm keen on is, like, for C#, there is an old, not part of Eclipse, Leo, I guess, I'm not sure. There's an old library that every now and then gets itchy and wanting to sort of revive it. It could be that it works, I just haven't used it myself. So if there's interest, that's really one of the closest one I think we can sort of try to revive, is the C# library, is the one I know of.
Okay, I know of a couple. There is an open source project called OSLC for JS, for JavaScript,
Right.
Which has a pretty functional OSLC client. I have developed a number of a Python API that I'm using internally, and we're going to hear a talk later today about Python. Swift at the moment doesn't have any that I know of RDF support, so that's a big barrier to that one. Another question that came up is how can I contribute to Eclipse Leo?
Yeah, so I have a link at the end of my next presentation. Jim, you're hello?
Yes, Jed?
Yeah. Sorry, I thought you were speaking, but I got confused. Yeah.
Nope.
So in the end of the my second presentation, I have sort of some pointers for the on how you can contribute. But it's essentially about joining the Eclipse community, signing a paper, and then you're more than welcome to join. We can have a dialogue on where you can help and in what parts. It all depends on your interests, of course.
All right, Jed, I think we're ready for your second talk. Okay,
so I will continue from where I left also. So yeah, let me just see if I can do that. Right, so this is an application, and as I said, nothing of what we do is really dependent on Eclipse, the IDE itself. But so this is a standalone application that you can just start with a, you know, it's an exe file. But of course, you recognize yourself. It's built using Eclipse plugins, so let's not hide that. What we have here is just you know, you can create a project, and in the project you start modeling. I'm not going to show you those steps, but it's pretty much quite lightweight way of modeling. And I will show you a ready model. So this is sort of a toolchain view where you can specify what kind of servers you want, what kind of clients you want, and you can have a combination of that also. I'll show you how. And then once you have one of these servers, you can dig a little bit deeper, and out of the box you get like just a pre-configured, you know, service provider catalog, and then you can say, okay, I want a service on the service provider. This is my domain. You can add whatever capabilities you want to it, that kind of thing. You can have multiple services on the service provider. You know, it's really following the standard. You don't have to understand the standard. It just we make sure you do that. You behave properly. I can't add a resource here. I have to add it here, for example. And here you can see you can choose what resource you want. I'm just doing you a graphical way. And then, for example, this is a resource, and you can see that the I'll show you the information model later. That's pretty much it. And you configure your server. So you say what your Java package is, what your server configuration stuff is, what URI you want it to run at, etc. Because we generate, once you have that, I can practically just right click on this, and I'll show you that a bit later, and then just generate the whole class, and I'll show you what you get out of that. Just to show you a more complete model, this is a requirements model where I have that. I'll remove the TRS. I talked about this TRS. If you want TRS support, you can just, you know, drag and drop, and all you need to show is just the pages, the TRS base and changelog, the page size, and when you generate, you're going to get that service. Pretty much 99% are pre-generated. A new thing we've just done is authentication. So especially if you want to integrate with Jazz.net applications, you can just add your authentication. You say, okay, I want authentication. Very few parameters here, and then we can get all the code for you, which is very troublesome to get both OAuth 1 and basic authentication out of place. Of course, you still need to do the code that connects to the backend tool to do the actual authentication. But we take care of all the repetitive stuff that you have to do for every server. We don't have to do that anymore. I hate repeating myself. So this is one way of sort of getting it for all my adapters at the same time by doing that. What else do I want to show you? Yeah, most importantly here is, of course, the information model. So here you can see that this is actually the domain specifications. Of course, OSLC, I'll show you the OSLC ones. We've already modeled the OSLC ones. So if you want to use one, you can just import these objects, import this project into your modeling yourself, and then you can reuse them. And that's what I did when I tried to add automation requests. That's coming from that pre-created model. But you can also define your own objects by simply just creating a resource shape and adding properties to it. It's like a class diagram, but it's not really a class diagram, because you really, if you look at the properties of a property here, you know, this is reflecting, this is not a class object. This is an OSLC resource. What representation you have, what is its range. This is all according to the OSLC standard. And everything you do gets reflected here, of course. You can inherit from the core domains, etc. as well. by doing this property here called extends. I won't show you that one. So, and that's it. And once you have one of them, you can just, let me just dare to, I think this should generate. It's not foolproof, so somehow you need to know what you're doing also. You can just right click and then generate, and then tell it where you want to generate, and that will produce, I'll show you what it produced. But it's going to go through and produce the standard Java template for that. And now I'll move to my environment. This could be easily be IntelliJ. And here, let's just open that project I just generated, just to show you what you get out of the box. Oh, I don't know where I generated it. Okay, let's keep that for the sake of time. I'll tell you what you get for free and what is it you have to implement. So this is the adapter RM. This reflects this project here. What you're going to see is the resources. Based on your specification, you're going to see what I showed you before, the class requirement with all the OSLC annotations to make sure it gets serialized into RDF in the right way. That's all its properties, title, description, etc. So you can create instances of that. You will get the web services for the service provider catalog, and that's the one that lets you navigate from a service provider catalog down to a service provider. So this is the service for the service provider, and here you will get your query capabilities. These are the classes, these are the methods to do query capability, and that is reflected by this query capability, because I said I want one. If I remove that from here, it's gonna, when I regenerate, it's gonna disappear from here. And then I have also my web services to be able to do get, update, delete of a requirement. Here they are. And that's because I have this thing here saying I want to have a requirement. You can add, you can do any kind of configuration that is reasonable. One service can have multiple resources, one query can have multiple ones, etc. What is allowed by OSLC is allowed by here. And you can see in this code that I have these repetitive start and end. What you do is when you regenerate, all this code will get overwritten. But if I add something here, when I regenerate, this part is not going to disappear. So really, you can start with modeling very simple, generate, improve your code, then regenerate, change the model, and then you don't get penalized. You don't get, these things don't get removed. So we try to put this to let you customize everything. But all these services and the resources, they're pretty much, in most cases, you really don't wanna, you don't have to touch them. The only thing you have to really work with is this class, the manager. And that's where, depending on what you've specified, we're gonna generate these sort of templates where you say, okay, this is the only thing I need, get a requirement, given that it's ID. And all we're asking you to do is just, when you first generate it, it will look like that. And then you just have to fill in the information here that tells it how to get, this is how you connect to the backend tool to get the requirement, and then you put it here. And that's it. How do I delete a requirement? I can't do that. I mean, Leo can't help you with that. So that's the kind of stuff you need to do yourself. Okay, that's the only class you sort of normally want to touch. If you have authentication enabled, you will get an authentication class, and then there will be a method there, a stub, where you have to tell us how to connect to that tool and how to save it in the session, etc. That's pretty much, I think, what I wanted to show you. Maybe I can run this without saving. Just to show you how it is when you run it while we're at it. Let me just look at my script to see if I showed you everything I want. Yeah. Yeah, and then also, of course, while this is running, I can show you this feature where you're, if you have a model, you don't want to really build everything from scratch. So you can just add, import other models, either because we've published them. For example, this is the standard model for OSLC that you can add to your system, and all of us, and then everything in this specification here will be made available for your model. So you can build your model based on that. Generally, I will have a project for my specification. So I put my kind of information model in one project, and then the adapters will be in different projects, because then I can reuse the same resources in multiple projects. So you can compose your model in very different ways. It's pretty flexible. Normally, this doesn't take as long to start. This is worrying, typical. Right, let me see if it started now. So this is just an example of a server. This is a front page you get. And yeah, so what we have also out of the box is you can have this integrated Swagger UI interface. So you can use that to navigate your services. And we structure this based on the OSLC standard also. So if you want to get a requirement, you can say, okay, let me test this service here. And then you say what format you want and you execute it. If you're familiar with Swagger, this should be quite standard. And then you get the results. So it's sort of an integrated way of testing your server. You can also, these are debug pages. This is not really OSLC, but we give you pages that build on whatever this is all generated. So you can sort of navigate from your service provider catalog to the different service providers down to your different services. Here are my queries. You can get different queries, different results, and then you can actually navigate to each of them and get that information. So it's a very good debugging kind of tool. We also give you an example window where you can search and do the delegated UI. Apologies, these are very ugly kind of pages, but that's the best when it comes to HTML that I can do. So there's a lot of space to help and make them a little bit nicer to work with. TRS protocol, that's already straight out of the box. You can see what objects there are there. There is no changelog because we haven't done much at the moment. But if I go to, let me see here. If I sort of create a new resource, this is just a mock-up tool. Now I've created a new resource. You will see that if I do here, there you go. You've got this changelog sort of automatically here. This particular resource has been changed, etc. That's it. Let me see. How much time do I have to see how much I can talk a bit more? Jim?
Yeah, you still have 8 minutes.
Oh, okay. I rushed through things. Let me see. I'm happy to take more calls actually, or if Jim and Andre can help me discuss more of what we can do.
Well, I will just say that I have very recently used Leo Designer myself to create a prototype implementation of an OSLC server for SysML v2. That's ongoing work at OMG. And JAD has improved this significantly from the last time I used it. And I think this is a very significant contribution to OSLC that really reduces the barrier to entry for new domains.
Yeah. And that's actually, thank you, Jim. And that's how I've actually worked really, is that whenever someone has a need, I mean, I have my own needs and I update it, but it's really when you come, Jim, and say, oh, how can we do this? And then that's what sort of motivates these open source projects to improve it, because if you have this need, I'm sure other people have this need. So this is where this really depends on the community, on where we want to go that way. I really wanted to do authentication, but only when I needed it, or in this case, when you needed it, Jim. Then we said, okay, let's put some effort onto this part. And that's when we did it. Yeah, so let me wrap up then with just a couple of more slides, because we want to talk about the how you can contribute also. So you can see this, I mean, even if you're not into model-based development and code generation, you can see it as a very fat wizard that instead of you writing some, I mean, I hate doing all these POM files specifying my dependencies, all my services, etc. You can just draw this picture, generate it, and then you never have to go back to Leo Designer. Then you have a core skeleton for an OSLC for J project, and then you can develop it on your own if you don't want to go all the way with model-based development. We give you the classes that I showed you that correspond to your OSLC resources. That's really relevant if you're not only sticking to the OSLC specific standard domains. All the YAX-RS services will be there. Whether which ones do you want? The query, the delegated UI, the CRUD. We give you that. We give you basic JSP pages to represent these dialogues. So I'm not a JavaScript kind of person, but Andre helped me with defining these JavaScripts, and then I can reuse them and I look like an expert, because all of a sudden I have them in all my projects for delegated UI. There's a lot of debugging pages like you saw. That's really helpful to try to work. So you don't have to work with the REST calls as a machine. You can really look at the code with friendly HTML pages. Maybe these don't need to be improved, but it would be really great if someone is interested to really improve our delegated UIs. These pages we can do a better job than that. in terms of making them, you know, sort of what we generate is a bit more attractive, let's say. You get the Swagger integration, so you can use Swagger both for documentation, but you can also use the Swagger information to generate your clients that correspond to that server. And I think we'll be talking more about that in the following presentation about Swagger. TRS server, as I showed you, it's an in-memory prototype, and I think the next step for me is to really start thinking about how to do to make this persistent. So if there's any interest in that, that would be interesting to hear about, actually. And then, yeah, authentication and integration with Jazz. We produce the authentication, OAuth and basic, as well as the discovery capability, and that's pretty much what we need to integrate with Jazz applications. And then you don't have to be afraid of, you know, generating code, modifying it, and then generating again. So work incrementally if you want to use this application. That's it. This is a very quick, very rushed. I panicked when they said it's 20 minutes. So that's it for me for now. And I hope it's enough information just to make you interested in this project. If you're interested in contributing, this is the link on what we, you know, sort of the tips, but it's pretty much about, you know, send us an email saying, look, I'll be interested in contributing, and we're more than happy to help you along the way. You'll have to sign the paper in the end somewhere. But that's because of Eclipse's requirements on making sure your contributions are proper open source, etc.
Jad, we have around 4 questions on TRS and Lio Store, so maybe we can use 3 minutes for that. Yes,
Andre, when is the time to, we have the thought of a poll if people are interested in a more detailed introduction to Lio. It would be interesting to hear from the community also. That would be interesting.
I will start that poll now.
Yeah.
We're closing the poll on who's using Lio. 60% of people are familiar with Lio and around 40% are not.
Okay.
And this is the new poll for the workshop.
Yeah.
In the meantime, the first question is, could TRS server use Lio Store to persist the changelog?
Well, this is actually the next thing to work on. To make it persist is not implemented, right. But I'd really like to get that going. Yeah.
And will Lio Designer generate an implementation that uses Lio Store and TRS providers?
Lio Store, it's as itchy as TRS provider, and actually quite easy. So what I would like to do is, you know, same as you do with TRS, you should be able just to drag and drop a Lio Store here, configure it, tell me where your server, your database is, and then sort of get that in place. It's a very initial, I mean, it's a manual pattern I do all the time when I use Lio Store, so I'd really like to implement that. So again, whoever's asking the question, if there's interest, I'm happy to discuss how you'd want to use it.
Right, so the other one was if Lio TRS can support work in a cluster. I've answered that one on Slack.
Okay, thank you, because I wasn't, yeah.
Another one is what persistence a provider uses Lio Store. I also answered it on Slack, but briefly, while we use Gina, we use Sparkle, so we can basically interface any triple store you have, but also we can use TDB on disk or in MEM.
Yeah. The most active connection is with the Sparkle endpoint. We haven't kept up with the TDB, right? But yeah, so and if you have a Sparkle endpoint, you can integrate, you can persist with Lio Store.
And attendee number 25, thank you for being ready to share a persistency layer progress with us. Just either chat me or Jad on Slack, or if you're ready to discuss this in the open, just go to the hash Lio channel, and we would be very thankful to see what you've done.
Yeah. Yeah. Is it interesting, Andre? You answered questions on Slack. It could be interesting to hear for the rest of the community, maybe, about those questions.
Definitely. The poll results are almost in. We got 8 answers, and so far 88% of people are interested in a 3-hour plus workshop that would give a more in-depth and hands-on Lio understanding to people.
Okay, let's see how we can get that organized. Okay.
All right, thank you, Jad. As always, excellent presentation, and very happy to see the contribution that you've given. Thank you very much.
Thank you, Jim.
Our next speaker is Luis Ramirez of Connexus. Luis will discuss expanding code generation capabilities of Leo Designer and OSLC service documentation using a set of open API extensions to support OSLC concepts. He will show how to add these extensions to an existing open API specification file and how a Swagger.io code generator can process them to generate an OSLC server. A quick reminder before we start, submit your questions on the Pulse app and we will respond to them as best we can. So Luis, I see you're ready to go. Off to you.
Yes, can you hear me clearly?
Yes, very good.
All right, perfect. And you can see my screen, correct?
Yes.
Excellent. So hello, everyone. My name is Luis Armando Ramirez. Today, I'm going to talk about open API extensions for OSLC. And yeah, this is a proposal that aims to enhance the experience of developing OSLC APIs. So who am I? I'm a software engineer at Connexus since 2019. There, I have worked with in projects that involve technologies like OSLC and integrations with IBM Jazz. I have also worked with Swagger and OpenAPI, two technologies that I'll dive into in this talk. I'm from Mexico City, and although I'm not in Mexico in this photo, I'm in Canada. This is Mexico City. It is a photo of the Angel of Independence on Reform Avenue. You're invited here anytime. Before Connexus, I co-founded a software development company here in Mexico, Sisu Technologies, where as a technical lead, I develop and manage projects across several industries. There, after several projects involving web APIs of different styles, one of the most valuable lessons I learned was to never underestimate integrations with third-party APIs. So to be able to talk about open API extensions, we need first to understand what is open API. Open API is a specification to describe web APIs. Essentially, it specifies endpoints with the verbs they accept, their request and response bodies, or the resources they manage. Let's take this example on the right. It is a very simple open API spec. It describes an API with one endpoint users and accepts two verbs, get and post. The get method returns an array of users, and the post method creates a user. We can see the definition of the fields for a user in the schema section below. We can write an OpenAPI specification either in YAML or in JSON format. This example is in YAML format. Now, OpenAPI has its origins in the Swagger project. Swagger is a project created with the goal to generate API documentation and client libraries. The Swagger team designed a structure or specification, originally in JSON, to define the API and a set of tools that would consume it and carry these generation tasks. Now, this spec and tools were later separated into different projects. And while the tools kept the Swagger name, the spec was rebranded, let's say, to OpenAPI. We can then define the Swagger as a set of official open source tools that can take either as input or produce as output an OpenAPI spec. These are the Swagger tools I'll talk about in this presentation, so it's important to know at least the gist of how they work. Let's start with Swagger CodeGen. It's a code generator that produces server, stubs, and client libraries from an OpenAPI spec. It supports many target languages and frameworks. So now let's see it in action. Here I'm going to take this specification file I showed previously and feed it to the Swagger CodeGen command line tool. I'm specifying to use the Java JAX-RS server generator here. It's important to mention that the generated server stub design has a separation between the implementation and the API-related code. Next is Swagger UI, possibly the most famous tool from Swagger. It generates an interactive HTML representation of OpenAPI that can serve as a public-facing readable documentation. And finally, we have Swagger Core. The Swagger Core library includes a set of Java annotations that we can add to the endpoints and models with OpenAPI meta information. Swagger Core also contains a generator that can read these annotations and produce an OpenAPI specification that it's then made available at a specific endpoint in JSON or YAML format. As I mentioned before, the development of OpenAPI and Swagger are separate efforts. The OpenAPI Initiative Group oversees the evolution of the OpenAPI spec. Here's a list of its members. As you can see, it's an effort that is managed by several big names. Now, how does Swagger and OpenAPI work in a real development scenario? At a high level, there are two main approaches or development pipelines: code first and API first. And I'm going to describe both methods assuming a Java environment. And I'm going to take this opportunity to say that this talk would mostly be based on Java, since there is good tool support both in OpenAPI and OSLC based on that language, in OSLC through Eclipse, which we just saw. We can easily create with this a proof of concept, but the same general principles that I'm going to show you apply to other languages. So now the code first approach involves adding Swagger core annotations to an existing API developed, for example, in JAX-RS. From here, the Swagger core generator produces an OpenAPI spec. We can then provide this spec to Swagger UI to generate the documentation, and to Swagger code gen to create a client that consumes each endpoint defined in this specification. When there's an existing code base, developers usually use this pipeline. Now, the API first approach involves writing the OpenAPI spec first and passing that to the Swagger code gen to generate a server stub that we can then implement, or a client library. We can also supply the specification to Swagger UI to create the API documentation. Now, the server stub contains the Swagger core annotations. This makes it possible to generate or regenerate the OpenAPI spec and make it available for other services in an endpoint. This setup will ensure that the publicly exposed API, OpenAPI spec, is always synchronized with the code. Now let's take a look at one of these approaches in practice. Eclipse Designer, it's a tool that we just saw that where developers can model OSLC APIs visually and generate from the model an OSLC API on top of a JAX-RS server using Eclipse OSLC 4j annotations. In the latest version, this option to generate Swagger documentation was added. Lio Designer generator adds these Swagger core annotations to the generated code. From here, the Swagger core generator builds and adds an endpoint that returns the OpenAPI spec built from these annotations. The project also comes with Swagger UI, so the specification URL is passed to the Swagger UI to generate documentation in HTML. OSLC, we have to remember that OSLC defines a standardized structure of endpoints and defines other characteristics for resources such as relationships. OpenAPI doesn't know these concepts. It only specifies endpoints and resources. But what if we could add these OSLC concepts to OpenAPI? With this, we can have a world of possibilities. For example, generate OSLC APIs for other platforms using Swagger CodeGen. With this, we can potentially, for example, target other frameworks and languages in Eclipse Lio Designer with minimum effort. This is something that I talked with Yad, and after developing this approach, where we can, for example, have an option in Lio Designer to output an OpenAPI spec instead of the source code. And from there, we can generate the corresponding code. We can also have the possibility to reflect OSLC constructs in Swagger UI. But how can we achieve this? How can we add these concepts to OpenAPI? OpenAPI comes with this feature called vendor extensions. Essentially, they are custom properties. Here's an example. AWS API Gateway allows building an API from an OpenAPI spec. API Gateway allows plugging in other features to endpoints like request validators. To do this, API developers must add the respective extensions that are defined by the API Gateway service. These extensions are then processed by the platform. OpenAPI vendor extensions are defined with an X- prefix, as we saw previously. The Swagger tools can parse these extensions. Now, besides AWS API Gateway, services like Microsoft Flow and Azure API Management make use of OpenAPI extensions. With the use of OpenAPI extensions, we can introduce OSLC concepts to OpenAPI. Here's an initial proposal of extensions that we can define for OSLC and the place where we can add them inside the spec. And here are some examples of how they would practically look like inside an OpenAPI specification. After running these annotations to the OpenAPI spec, we can then configure the Swagger tools to read these extensions and modify the output. Let me show you an example. In the following demo, I will take the OpenAPI spec generated from Live Designer OSLC API sample project and add the OSLC extensions to it. This new and extended OpenAPI spec will be passed to Swagger code generator as input. CodeGen will then output an OSLC API. To do this, we are going to customize Swagger CodeGen. Swagger tools have a certain degree of customization. CodeGen, for example, uses a templating language called the Mustache to generate all the project's source code. CodeGen accepts as an optional parameter a folder with custom Mustache templates. With this, we can modify the generator's output. To prove also how far we can modify the output, I'm going to modify the JAX-RS generator templates to output a Spring project with JAX-RS integrated to it, instead of the Java EE project on top of Jetty that the default generator uses. So here is the OpenAPI spec file. I'm adding the OSLC extensions to the test script model and endpoints. It's going to have a creation factory, a query capability, and both are going to be included in this service provider endpoint. And I'm going to have also a research shape endpoint. In this folder, I have the custom templates which will parse the extensions. Here I'm adding the OSLC 48 resource shape annotations to the OpenAPI models that will be generated. And over here, I'm adding the annotations to the endpoint code. Let's run the Swagger CodeGen command providing the extended specification and the custom templates. We'll see that it produced the source code. The code has a division, as we saw before, between API and implementation. In the API side of things, we can see the OSLC 4J annotations added along with the Swagger code generator ones. Well, the Swagger core, sorry. We can also see these annotations inside the models. Notice that the models extend from the abstract resource class that is from OSLC 48 that provides some base functionality. In the API implementation, I'm going to modify this to return a dummy test script in the endpoint to get a particular test script. Now let's run the project. We're going to see that it's a Spring Boot project. Since Swagger core annotations are included in the generated code, the OpenAPI spec is going to be available at this endpoint. Now let's open up Insomnia and query the service provider. As you can see, the query capability and creation factory are listed. The creation factory also points to the test script resource shape, which we can query, and it will return the information of the resource shape. We can also see that the endpoint to get a test script by ID works. It can render RDF since I included the OSLC Gina provider in the custom template code. Now, the next steps, aside from finishing a complete first version of the template overrides are, well, first of all, Swagger code generator doesn't include the extensions in the Swagger core annotations of the generated code. Therefore, we can't do, let's say, the reverse process of creating an OpenAPI spec from the annotations. For example, we can't regenerate the original spec file from the source code we just generated. We need to add this manually in the Mustache template overrides. Next, we need to formally define the extensions. And now with the extensions fully established, we can customize Swagger UI with plugins to show OSLC information in a more meaningful way, or have a more complete information. Finally, we need to explore also the possibility of creating clients for the generated OSLC APIs. It is possible using the same template override mechanism I showed you, but the client design must be modified to consume the OSLC API in an auto-discoverable way, instead of having a library that just calls each endpoint, that it's the default design that code generator provides as output. Using OpenAPI to describe OSLC services has its challenges. I consider these the major ones. first we need to figure out how to support RDF formats in Swagger UI inside the samples. And second of all, OpenAPI and therefore Swagger don't have support for OAuth 1.0, which is required by the OSLC spec, although it has support for OpenID and OAuth 2. I invite you to contribute to this effort. In the end, I believe this will help boost the creation process of OSLC APIs, and complement also the LIO designer's code generator, and popularize OSLC by leveraging a well-known standard and reduce the friction of API developers into OSLC. We're in the process of releasing this first effort to, let's say, more official channels. Right now, you can find the message templates that we saw inside my personal repository. So thank you very much. So I don't know if anyone has any questions.
Thank you, Luis. Let's see what we have for questions. Let's see, how will this feature be made available? Is it open source?
Yes, the idea is to open source the, well, at least in this first effort, open source the templates and also have some instructions of how to generate the code using Swagger CodeGen with these templates. And also we need to, let's say, document these extensions to say, these extensions, they go inside this part of the API. These extensions go in the models, for example.
Okay, another question is, can you say how OpenAPI for OSLC relates to JSON hyperschema? JSON hyperschema is just another, let's say, another way to document or define an API. Unfortunately, JSON hyperschema doesn't have, let's say, the tool support that OpenAPI has. OpenAPI has a lot of tooling around it, and it's backed by several companies. It's also a very popular and very well adopted standard compared to JSON hyperschema. Both, let's say, have their pros and cons related to how they, let's say, we can translate or adapt them, let's say, to an OSLC, let's say. Okay, next question is, do you see this as a full-featured alternative to the graphical modeling that we saw in LIO Designer, or a supplement to it? How do those two relate?
Well, it could be, right now, it could be a very good supplement to the graphical model. The issue, of course, with defining the entire API inside OpenAPI is that it's mostly a text-based format, and you still have that, let's say, issue. If you were to write the OpenAPI specification, let's say, by a text editor, there is still work of possibly repeating some parts and having some repetitive tasks that a tool like LIO Designer can very well solve in a graphical way. So it could be first, an alternative, but also LIO Designer can output from that model an OpenAPI spec with these extensions, and from there it can expand, for example, the target languages and frameworks that it can generate, instead of possibly just having as an output a JAX-RS Java server.
Okay, the next question is, could you use this feature to generate, say, a C# OSLC server?
Yes, yes, totally. OpenAPI comes with a way to, well, Swagger code generator has a way to output C# code. So yeah, we'll just need an OpenAPI specification with the extensions and create a template overrides, and with that we can create a C# code.
Well, I think we have time for one more question. It's one that's quite interesting to me. Would it be a good idea to use this with the SysML v2 API, which is also expressed as a Swagger file, to create an OSLC-based SysML v2 API?
I'm not 100% very familiar with the CSML standard, but if it, I will have to look into how it's structured to see the feasibility to do this.
Perhaps I can answer that question. The SysML v2 REST services API is still under development, and what we're trying to do is incorporate JSON LD context into that and have it be their JSON B, JSON LD. Once they do that, that is already an OSLC server. Basically, it's an OSLC server that has a very limited number of capabilities, just RDF representations of resources, which is fine. So any number of techniques could be used to extend that REST API with additional OSLC services. So I think stay tuned, more work to come on that.
Yeah.
All right, I think we're out of time on this. Thank you very much, Luis. Very interesting. Our next speakers are Christian Muggio, the project manager and team lead of engineering transformation at Contact Software, and Mario Carusco of Connexus. I hope I'm pronouncing these names at least remotely correctly. If I'm not, please correct me. They're going to talk about PyOSLC, a Python SDK for OSLC APIs. I have also been using Python to access data from jazz.net through OSLC and various other query and reporting tools that are supported by those products to do ELM quality management. So I'm very pleased to see this connection between OSLC and Python as a means to further exploit and expand data integration into data science application development. So Christian and Mario, I think you're ready to go. I'm seeing your screen. Are we hearing you?
I hope so.
Okay, I think we're ready to go. Thank you.
Great, thank you, Jim. Yeah, the following presentation will be a shared presentation between Mario and me. And I will start with some quick slides. What the motivation for us is to be the sponsor, so to say, for PyOSLC, which is programmed by Connexus and will be open sourced later on. And maybe if you have taken part on OSLC Fest 2018, maybe you remember our chief developer, Frank Patz-Brockmann, who presented the approach, the beginning of the approach 2 years ago already on the OSLC Fest. Yeah, as Jim introduced me, I'm a product manager at Contact Software. We are a PLM vendor. And besides that, I'm co-chairing the OMG Mantis domain task force. And yeah, as I said, we are coming from PLM and so to say from mechanical engineering in the past. So we are 30 years on the market now. We are definitely not the biggest PLM vendor, but we have pretty nice solutions and pretty nice technology stack, which is based on Python. And that's why we wanted to have a OSLC API or integration for Python and make it available also for, like Jim mentioned it, for all the artificial intelligence stuff and so on. And there's many applications, different applications which are running on Python. Yeah, so we are very committed to openness by supporting the Code of PLM Openness in Germany by the ProStep Association, and also to support this project for OSLC. And this is very natural to us because we are not coming from a ERP or CAD solution. We were PDM or PLM, pure PLM from the beginning on, and we are dependent on integrations. And OSLC is pretty promising for me and for us, that we can develop it not only supporting or being focused on ALM or software development specifications, but that's another story. So I'm not a sales guy, so I'm quick going over our technology stack. So we have some technology components, and this is exactly where the OSLC, the Pi OSLC implementation would be integrated on our side. We have some core services and build on those some domain applications. This is looking a little bit like that one, like a period system. And yeah, as I said, we have already a technology part in our platform called Web Service and Interoperability. And we will bring Pi OSLC in there just to add a new functionality besides pure HTTP REST integrations or the old XML gateways and so on. So just another 2 or 3 slides from my side, what the motivation for OSLC is and what the idea is, what we like. But on the other side, when we discuss with people about integration and data exchange, yeah, I see that many people can't really distinguish between those things. And maybe the OSLC community and all the vendors implementing OSLC have to make some things clear. So, and looking from a data management and a data model perspective, people want to connect models all the time, and they ever want it and they ever will. And coming from a data model view, I would say there is always some container-like views or some containers containing also metadata and so on. And the real interesting thing for the end user is the payload inside the container. And what people are doing, or what they are also thinking very often, unfortunately, when they are talking about OSLC, is like picking this payload of the container, copying the data into a new container on the Model B side, and that's it. But this is exactly what OSLC is not, and in many cases, what users don't want or need, especially when they are inside one organizational context. We still have the problems between different organizations. Yeah, you want to have a real copy of the data, but especially inside one organizational context. This is the thing that OSLC offers, and we hope that we can support this further on, also in the domain of PLM, to say you have a dummy object on the right side or a dummy container which is just containing the link, and you pick all the payload, all the real information, for instance, the natural language sentence inside a requirement that you pull from the original model, deduplicating data, always being always being able to request the latest version, and so on. And what we offer then is some kind of overlap of model information, but with avoidance of data duplication. This might look very obvious for you, but I showed that up because in so many discussions I experienced that people cannot distinguish between data integration and data exchange. And this overlap of information, this is necessary. So if you don't have this overlap, you never could connect information to each other. And we see that in engineering, in the mechanical and electrical engineering, as well as in the software domain. Yeah, and this is a little bit the motivation, bringing technology, establishing this into our platform, which is based on Python. And so I would hand over to Mario, and he can tell you all the technical stuff in which you might be interested more, how PyOSLC is made.
Hello, everyone. Can you hear me?
Yes, we can.
Yes, we can.
Thank you. Hello. Okay, nice to greet you all today. I will talk about PyOSLC, the Python SDK for the OSLC APIs. Let's start it then. Okay, my name is Mario Jimenez Carrasco. I'm a senior developer at Connexis since 2018. I am backend developer, mostly with Java and Python. I have worked with JAX, RS, Spring, and Flask, among others technologies for developing REST services. In these 2 years, developing services for OSLC, liquid data, for integration with IBM CLM application. I'm Mexican also. And well, let's start talking about PyOSLC. We are taking the advantage of the popularity of the Python for spreading the implementation of OSLC APIs. This is the architecture we are using for implementing the PyOSLC. We are using Flask as the framework for creating the API. We are using also an extension, which is RESTX, previously called REST Plus. We also are using the RDF lib, which is the most important part of this implementation, which helps us to create all the graph and the triple for converting the information into the RDF. And also the JSON LD format to create the RDF representation using JSON LD. Okay, the SDK is aimed to create APIs for serving information that could come from different sources. In this case, we could see that we are using, for now, for this example, we are using CSV file for reading the information that could be some different elements as requirements or other kind of information to expose the information into the OSLC API. Here, for example, we could see how the traditional API are implemented and how we could achieve the implementation of OSLC. While traditional REST API has custom endpoints and resources, we could imagine that all the APIs implemented by the owner are customized by their requirements. Using the OSLC API, we have to standardize the resources to describe the services that this API offers. In this case, we could see that we have a service provider catalog that is the main entry point of our API. By knowing this service provider catalog, we could discover all the elements within our API. Based on the representation of the service provider catalog, the client could find all the available service within our API. A common service is a query capability or creation factory. All these elements are based in the representation of RDF. Here, for example, we could see how this implementation could be achieved. The OSLC service provider catalog refers to a list of service provider resources, which describes some kind of data container, such a project or a repository or other kind of resources. In the example of having data in CSV file, its CSV file could be a project or a source of information. Here, for example, we have the information of the CSV file as a service provider, and each element within the CSV file could be a resource. Okay, let's see how this works. In the RDF representation of the service provider catalog, it's typically to find the inline representation of its related resources, such as service provider. We have here the service provider catalog, and it has include the service providers, the services, and the query capability. This change describe how we could find the elements within the API. In the REST API, in a standard REST API or a traditional REST API, we need to know all the endpoints before to do the request. Using the OSLC API, we only need to know the service provider catalog, and using the service provider catalog, we could discover all the elements within it. Here, for example, we are using, or we are creating a request for the query resource to retrieve the list of resources within the container. Here we are seeing all the requirements within the CSV file. Here, the representation of a resource describes a domain-specific such a requirement. In the example on the left, you can see the requirement properties described in RDF. Here we have all the attributes defined in the vocabulary of the requirements. Remember that the OSLC specification uses different vocabularies to describe the resources. We could have generic vocabulary as the RDF and OSLC, and we also could have the specific domain vocabulary for representing the requirements or other kind of elements. The representation of the requirement in RDF can conform to predefined RDF vocabulary, as we could see here. Okay, here the RM specification is defines all the vocabularies, all the elements to describe a requirement. We have here an example. Here we could see all the vocabularies uses for the representation of this resource, and we are seeing all the attributes assigned for the specific requirement in this case. The implementation of the PyOSLC requires to define some classes in Python for creating or for uses in the implementation of the resources to expose in the API. All these classes needs to have a method to translate the information from the Python object to the RDF format. We also are using the OpenAPI specification or Swagger to create some elements for creating the self-documented API. Here, for example, we have the HTML implementation of the OSLC API. Using the Swagger, we have the list of the elements of the endpoints for the adapter, or if you want to create a specific domain application, you could see the elements. And also, we could have the Swagger JSON specification for creating the code, the client, using the Swagger code generator, as Luis mentioned before. Here in this slide, we could see how we have implemented all the classes for having the resources following the specification of the OSLC. We have implemented the service provider catalog as a class for creating all the elements within it, and to use this class to expose the information through the OSLC API. We also have implemented the requirement class for having all the attributes available for creating these objects and to expose these objects through the OSLC API. Also, we are implementing the vocabularies for complying the OSLC specification. These vocabularies are implemented as an extension of a closed namespace, which is a definition of the RDF lib library. We are using the same approach for creating our own vocabularies for creating, in this case, the OSLC core vocabulary. And in the right side, we could see the OSLC RM vocabulary for creating our resources. For having the integration with external application, we have to define some maps to define which attributes of the OSLC should correspond with the external application. These mappings needs to be implemented before the implementation of the OSLC API, because we have to know which attributes should be converted in the specific property of the OSLC. In here, we have the specification, or sorry, the mapping of a specification resource with the requirement. We could define the OSLC elements, and we also could extend the RM or whatever custom attributes you want to use. Here, I'm showing you how we convert the Python objects into RDF. Here we have the capability to translate the Python into RDF using the elements or the library of the RDF lib. Here we are showing this resource in the turtle format. We could use RDF XML or JSON LD for converting the information. Here we have the process. We have the Python object as a requirement, and we have the implementation of the method to convert or the marshal or unmarshal the information using the RDF lib to convert the Python object into the RDF. Next steps for the PyOSLC. We are working now for creating the root services and service providers and the authentication elements for integrating the PyOSLC with the JAS CLM application. The final step will be the open source of the project. That's all for my side. Thank you very much.
Okay, we're a little behind, but not too bad. I'm looking at the questions. Will you release PyOSLC on GitHub soon?
Yes, that is the idea. We are working in the implementation of the elements for integrate the PyOSLC, or to help the integration of external application with JAS using PyOSLC. And at least we could finish the implementation of those features. We are thinking to open source the application, the library.
Very good. Well, thank you.
Thank you very much, Jim.
Okay, I'm very pleased to introduce our next speaker, Christoph Bergner of MID. I've had the pleasure to work occasionally with Christoph over the last few years, and I'm very interested in his contribution to delivering on the promise of tool integration. Christoph is going to talk about how we can move beyond simple linking of artifacts to richer ways of sharing and leveraging this federated data. Okay, Christoph, can we get you connected?
Yes, thank you very much for the introduction.
I hear you, but I'm not seeing. There you are. Now I see your screen.
Okay.
You're ready to go.
Good, thank you, Jim. Yeah, well, Jim was my great mentor in the first steps, and I'll also come back to that in the course of this talk. Well, thank you very much for joining this talk. Yeah, a very brief introduction. My name is Christoph Bergner. I'm owner of MID. We're a mid-sized company based in Germany and Switzerland, about 140 employees. And our background is basically modeling. So we have maintained modeling products for a very long time, so more than 25 years. We've offered modeling tools of all different notations and provide services in that area. Basically, the left half of this chart is authoring tools, and the right half of the chart is tools for tool interoperability. And so the one I'd like to talk a little bit about, or I'd like to demo some things, is SmartFacts. That is a platform that allows to pull models from the most well-known modeling tools like Cameo, Enterprise Architect, Innovator, Magic Draw, MATLAB Simulink, and Rhapsody onto one web-based environment, and yeah, basically provide easy access to models to anybody, allow to collaborate in the context of models, and also allow to do link management between artifacts of various different models. The second platform for tool interoperability is Toolbus. Here we go a different way, and we actually migrate models from one format to the other. So if you have a UML model in Enterprise Architect, you can migrate that to Rhapsody, for instance. Okay, so what have we done so far? So as I said, the idea is to allow easy access to models for everybody. So you can publish your native models to a web-based environment where everybody can search, navigate, do chats, reviews, comment on models, and of course to do cross-tool linking. In the next step, we have built an extensive integration with IBM Jazz, and we have started from easy integration without global config management up to global config management or projects under global config management and link validity and all these things. So that was a long journey and a tough way to go, I must say. But in the end, it's fascinating to see what you can do with OSLC and REST integration between platforms. In addition to that, we have built OSLC providers and consumers for other tools like Jira and Confluence, and especially I'd like to address Confluence today. So when I look back on, I think, 2+ years of intensive work with this technology, I must say the beginning was very encouraging. It seemed like a simple but fascinating concept. It seemed to do many things better than we had done it in the years before. And we also had an easy start. We had some first quick successful projects, and we really had fun working with this technology. But I also must say the experience was clearly real world integrations are still hard to do. So adding an OSLC link between two artifacts is not such a big problem, and you're pretty quickly you're at the point where you say, well, this works and I can see a delegated UI and all this is nice. But I really must say, if you integrate with big platforms like Jazz and so on, then this requires a lot of extra work, and they have their own rules. They still fulfill the standards, no question, but it really matters how the details are done and built, and how global configurations are done, and all these things. So integrating with big platforms is still a lot of work. All artifacts are versioned, of course. That doesn't make things easier. And it also means that linking always needs, in my eyes, always needs global config management. So you have to have an overarching concept that defines how versions of models belong together in a global configuration. And so this is the next step you have to address, and that was a challenge for us. Then there are things we had to learn when working with real users, that efficiency and usability is really a big point, and that required a lot of extra work for us. So there are some points like suspect links, link validity. That is something you have to support if you want to be efficient in engineering. If you don't have features like this, then it can be very tough to keep on with the schedules. Then a delegated search and select UI is a great concept and idea, but in many cases that's not sufficient. Like we have users that say we have to work with links the whole day, and like having to do 10 clicks to add a link is just, that doesn't work for us. You have to come up with something more convenient and easier. And I just like to switch over to Magic Draw here. This is what in the end we have done. We have integrated a whole doors next module here. So this is basically a reference into a doors next module. You can load the whole module into Magic Draw. It is rich text, it has images, it shows which of these requirements do have links, it has delegated UIs, you can follow links into diagrams, and you can very easily just select left, select right, and say, I want to add a link. And select the link type, and it's done. So, and we had to really come a long way to get into this kind of usability, where users said, yes, now we are in a scenario where we can use this in reality. Then integration with reporting is a must and can be a big challenge. That's, you have to bring your artifacts together in one place to build a report. You have to address global config management. So all these things can be a hard thing to do. So yes, it was a long way. We were really ambitious to make our users happy, and I think in many respects we have done some interesting things. So, and what I do not want to talk about today is how to link artifacts. I think that's the core ideas has been ever for the last 10 years, and yes, we know that's the core idea. But having gone through all this, is there anything we can do with this technology other than linking artifacts? And what I'd like to show is a very simple idea. There's nothing spectacular, but yeah, it makes life a lot easier for some users. And the idea is, in engineering we worked with a zoo of tools, many applications, and all of them are highly complex. Meanwhile, most of them have 30+ years or lived for a long time already, and all of these are complex. And many, I experienced this especially, for instance, in enterprise architecture. Often you have very simple tasks to do, like maintain a list of IT resources, maintain a list of servers or something like that. These people don't want to get into complex tools to do that job. They would like to have a very simple web-based user interface where they can do the job. And so what our idea is using OSLC to not link content, concepts, artifacts, but reference features and bring features into an easy to use work environment like Confluence. And so this is the idea, and the capabilities of OSLC perfectly match for this idea. And so we just tried it, and I'd like to just show you a few examples. So first, maybe an example I have here. I have just briefly before this meeting, I've set up a new Confluence page, and I have added some references into SmartFacts. So we have published models to SmartFacts of various tools: ARIS, Enterprise Architect, Magic Draw, MATLAB Simulink, Rhapsody, and I've just referenced these models. And this is what I have on the page. The first one is ARIS, then is Enterprise Architect, here's Innovator, there is Magic Draw, there's Rhapsody. And these containers, of course, do have functionality. So I can zoom in and out here. I can start commenting my model. I can even do a version comparison and say, compare this to version 1, and it will calculate all the differences and say, well, port 8 has been added, and I will be directed to port 8 and can see in the diagram what actually has changed. So this was the first step where we said we want to bring functionality we have in a remote tool, in a remote platform, into a function container, basically, that can live anywhere. It can live on SharePoint or in Confluence or wherever you put it, in Jira. And yeah, to go one step further, I just do one example here in Smart Facts. I can show you how that works. Basically, we have a global model warehouse tree, and in this tree there are all those different models that we have published. So there's a whole lot of different formats in here, and I can also store analysis here. So I define certain parameters, and I store, for instance, a check traceability analysis, and I say load that to the left, and I just press the start button, and this traceability analysis tells me which artifacts of a certain context I have chosen are linked to my requirements model. And I can expand the details and go on to that model and see the delegated UI of those requirements. So very clear is that this model element in this diagram is linked to this requirement. So I can do all these kinds of analysis. And now maintaining a agile team page, for instance, in Confluence, it might be interesting to provide these kinds of analysis reports functionalities. These are small chunks, they are predefined. We predefine them, put them into our global model warehouse tree, and then we reference them from Confluence. And for instance, here I have this traceability analysis, smaller, and I just get there, I click start, and I get the results. I can also say, well, don't show me those that are linked, those elements that are linked to requirements, show me those elements that are not linked to requirements. And that's a lot more. So I see my team still has a lot of work to do. There are a lot of blocks that live in block diagrams, which should be taken care of. We should have requirements for all these blocks, for instance. Or here is a different analysis. I say, show me a map of my diagram that highlights all elements that have links to requirements. And here is the map, and I can easily navigate into the details and understand how well is my model covered with requirements. Or here is an impact analysis. I have predefined some parameters for it, and I just click start, and I get, when a controller goes down, I get all the elements that are impacted in my model, and I can navigate into the details and understand what is actually impacted when my controller goes down. And at the very end here, I'd like to show again, of course, we also have that module I have showed you in Magic Draw. We also have it in Confluence. So we just select a module and say, well, expand the first 3 levels. And this will show us the one-to-one representation of doors next in Confluence. And right now it's only a read-only container, but yeah, there will be more functionality in the future, and we will also cover more tools than requirements management tools than just doors next. So yeah, so I think a little bit a different approach. No new technology, nothing spectacular, but we are always looking for ways to use OSLC in a way that makes it fun to use, easy to use, not many clicks to establish a link. Things have to be easy people are motivated to use them. And so we always think in these dimensions, and I get a lot of interesting feedback to this. For the future, for us, it might mean that we design our authoring tools a little bit different, so that that we have from the beginning, we design functions as functions that can be federated via a technology like OSLC. So somebody can easily also edit a visual model or edit the list of servers of an enterprise architecture. All these things could be done in a federated way. And that is something we're thinking of very intensively now as we also develop our authoring tools. Okay, that's it from my side for right now. And if there are any questions, I'm happy to take them.
Christoph, we do have a couple of questions. One is, you mentioned reporting. Are you handling reporting in SmartPacks?
Kind of, yes. I mean, we, of course, we also contribute to reporting to JAS via TRS. But as you have seen, we do a lot of ad hoc analysis. So analysis you can predefine, you can store the parameters, and then you can just fire them off and get the results. So it is not really a big reporting we're doing, but we're right more on those ad hoc analysis we provide. And when it comes to real reporting, then we contribute to platforms like JAS via TRS.
Second question was, how similar is the SmartPacks approach to OpenMBEE? Both SmartPacks and OpenMBEE present engineering information from different tools in a web user interface and support reporting. Could you contrast what you are doing with OpenMBEE?
I must admit, it's difficult for me. I don't know the details enough. I will take it. If you send me an email, I will find out and let you know. Okay,
very good. I think that's it for questions. Christoph, thank you very much. You have done some really incredible work. It's a real pleasure to see what you've been able to do.
Thank you.
Okay. I think we're ready for our last talk today. Lutz Lemire, I guess that's how you would say that. Of ProStep will discuss OSLC as an enabler for seamless application integration through OpenPDM. Okay, Lutz, are you on? And are you able to share your screen? I see your screen, but I'm not hearing you yet.
Hi, Jim, that's Lutz speaking.
All right, very good. Proceed.
I hope you see the presentation now in full screen mode. And I'm happy to talk about OSLC as an enabler for seamless application integration. I'm representing here ProStep, which is a market player for data exchange and system integration for more than 20 years. And I'm happy to present here our approach, how we will put in place for integrating large enterprise systems by our OpenPDM technology and how this is enriched by the OSLC capabilities. So I will do first some motivation where we are come from. Then I'm taking a look behind the scenes, looking into OSLC operations and give you a customer example. To make it a little bit more clear, we have already seen this type of motivation or introduction for a few times today and yesterday. We are coming from a field where we need to integrate over a large number of data sources coming from the PLM domain, change management domain, CAE and ERP, and whatever you want, name it, and it will be in place for some kind of integration need. And to be honest, the solution to such an example might be quite obvious if you are looking at in a green field and if you are starting a new company for a startup. But it's very hard for engineering company which has a great history and needs to stick to a lot of their design artifacts. And we call this legacies, and legacy enterprise integration is hard. And what usually needs to be done, why is it so hard? It's because to get an overall picture of what is going on in the company, what is the current state of your product development, needs to have some insight in all kinds of these systems. And not all of these systems are dedicated to a single use case. We have evolving use cases where you need to have information from different sources, and not all of these data sources are in the same place. So it's a question of fiddling around and shuffling with all the available sources of information, and we have the task to bring this together. And I will show you one of the approaches, which is quite obvious from the OSC point of view, how this will going to happen. But then, because usual approaches by large system vendors like Siemens or SAP, if they come to the place with a centralized approach, they are fine as long as they are really covering with their big elephant quite large chunks of the process and of the use cases. But hey, if you look into ongoing development, state of the art of technology, then there will still be yet another system to fulfill a new task. Let it be introduction of new ways of functional design, may it be a new way of virtual design collaboration tool. All this stuff needs to be integrated. So centralization is not really a feasible way, because it leads just to a timely solution, a solution for some time if it's at all achievable. But in the long run, it will not help in the dilemma of federating all the different data sources. So the other option is to make it possible for a single user to look into several data sources. Is an approach which ProStep was following for quite a long time. And we are quite successful with implementing this type of solutions. If a design engineer in the PLM system wants to know something about the provisioning of its design in the production area, then he needs to have some insight in the ERP system, and vice versa. The engineer in the production plant who wants to know which parts are ready for preparing for production needs to have a look into the PLM area. And so we end up with introducing some sort of duplication of key reference data. And this might be feasible if that's just a one-off adventure to exchange such an information. But as soon as the state of the part and the state of the material in the PLM or in the ERP changes, then you need to update this data, and you need to repeat the cumbersome duplication. And at the end of the day, such a solution is working fine for a lot of application use cases, but it works for a well-designed key data set only, and it's not a general cure for the overall challenge to integrate different sources of information. And this is our motivation to look into OSLC capabilities, to put the engineer who is in question of what is the proper source of information in the center of our picture, and giving him a capability to get information at the very use case he's working on with an up-to-date data by just referring to the data via OSLC, which gives us the linking capability as an open standard, which was initially motivated by IBM and driven by RTC, especially chess development, which gives us today quite a large number of available standard definitions, and it's based on the web. The web standards have the advantage of being very transparent to any kind of enterprise firewalls, and it's well understood how such data needs to be marshaled and unmarshaled and checked for consistency. OSLC comes with the whole stuff of development of new style of web interfaces with REST and some notion of authentication, which is applicable to a lot of scenarios. Furthermore, it allows, with its slim data model, a very easy, digestible representation of the exchange data, which is enhanced by a lot of RDF vocabularies in the change management, requirements and architecture management, and it's extensible. That is a very interesting feature for OSLC, so you can put in whatever you want if you are conform to some OSLC basics, then you can do extensions even if you are not in the lucky situation that you find a corresponding specification in the OSLC area. Client-server interaction is very easy. You search for an artifact in the connected backend system. You will get a selection UI where you have to choose an item for further usage, and this URL will be used for further lookup of that resource if the case you have to display the information. For instance, if you have a mouse over event and you resolve the URL previously obtained, then you can easily show up the up-to-date information from the OSLC server. And if you're lucky enough, then the drill down to the data actually leads to the current state of the information. So this OSLC link is not only a duplication as we have seen in the previous use case, but it has a live functionality which updates if desired and if necessary. What you see here in the representation as well is a link for an attachment, so you can even extend such UI by some further features to annotate the given information from the backend system. This annotation might come from another system, might come from the same OSLC server, or it might live in your own application. The same interaction, which is feasible in an interactive way, works for system-to-system synchronization. You can build up federation scenarios, and you can even completely hide the overall OSLC stack and its complete functionality from the client, so you can build up your own application on it, obviously. So it's a replacement of our duplication use case, because now you have an extended reference for a business object you are referring to. This is the so-called resource URL, which is managed in certain instances with the OSLC stack. These business objects are identifiable either by key and identifying queries or by standardized query capabilities. The schemata are described in a formal way, and same schema is used for producing different types of presentation. And once more, I want to point out the data model is much easier to digest in an enterprise environment and to be motivated for building up integrations in comparison to other data exchange standards like STEP for OMG PLM services, which are a lot more which are carrying a lot more of overhead because they are dedicated to transfer consistent and complete data sets and not designed for exchange of lightweight information like linked data. This gives me now, as a final point in my presentation, the outlook for how we use this in our PLM stack with OpenPDM, which is dedicated to be used for integration, collaboration, and migration, and especially for the integration and collaboration use cases. We have added our OSLC capability as an adapter, which works as a gateway to the OpenPDM universe, which actually integrates out of the box more or less all of the PLM, ALM, and a lot of the ERP systems with product level connectors. These connectors are speaking an harmonized and general API. So the OSLC adapter in-depth actually maps to this generalized API, exchanging the connector from Teamcenter to Windchill or something like that. If you are not changing the domain where you are accessing OSLC data, will be an exercise which is accomplished within quite a short time. And these connectors are interchangeable by design from a microservice infrastructure and are applicable to quite a long or a wide range of application areas. So OSLC is one option to be or to offer with OpenPDM this capability for systems which would otherwise not have this capability, which leads me to the essence of such a stack of technology. So an OSLC consumer would connect to the OpenPDM OSLC adapter, which takes care about authentication against the backend, mapping the OSLC query to the native query of that backend. It may actually fire back the query UI or the display UI if required. He may actually add some functionality, like I've shown the attachment capabilities, and it opens up the not OSLC aware databases for an OSLC scenario. The user perspective from this is the same as I've shown previously, and I've already shown that we extended this OSLC adapter capabilities with the attachment functionality. We have applied this to customer situation where we have an OSLC aware environment, but dedicated to homologation process, which is run in the Bombardier RTC and DORS NG environment. At the end, the task was to enrich this design environment by an homologation process and to create a statement of compliance so that Bombardier could deliver an authorized train to an local company which was following their local homologation guidelines. And to make this happen, actually we need to put in place product requirements coming from the homologation authority, which were captured in DORS NG environment. We connected this with the OSLC RTC capabilities to a project management tool, which had an work breakdown structure or about all the homologation tasks. And then we connected this OSLC aware environment with another environment which was not OSLC aware, which is Teamcenter Enterprise, and which stores all the product breakdown structure items, and then we could set up a complete link from the product requirements over the work breakdown structure task to the product structure items, add evidences, and control this via live links with OSLC, whether or not items are attached with actual evidence document, evidence attachments, and could produce a fully compliant workflow, which was fulfilling the requirements of the homologation process. And at the end, it was a perfect example for utilizing OSLC, what it was intended for. So OSLC Bridge by OpenPDM enriches the OSLC market by OpenPDM related systems. That's one highlight of this talk at the end of this day. And on the other hand, I would point out that with OSLC, we could update our capabilities within OpenPDM for a lightweight mechanism to integrate enterprise data, which is more appropriate to some less impact integration scenarios. It enables connected systems without copying data, which reduces requirements for data consolidation. And if desirable, OSLC is capable of conveying up-to-date data. So the linked information shall be or is up to date if desired, and if you are accessing design data, this is a big advantage compared to other means of coupling enterprise information systems. That's the end of my talk. Thank you for participating, and it's my duty to thank Carsten Zerbst and Frank Wagenknecht from PostStep and Bombardier Transportation for providing the example. Thank you very much.
Thank you, Lutz. That was very interesting. We have a couple of questions for you. Is there any news on supporting step data using OSLC?
Not to my knowledge. Maybe I'm the wrong person to ask this, because in that OSLC OpenPDM implementation, we are stick to the OSLC specification.
Okay, the second one is, what is the status today for using OSLC for linking using query and delegated user interface user experience versus syncing in OpenPDM? I'm not sure if you're able to see the questions.
Well, I'm not quite sure that I understand the question, because we may actually use this twofold. If you show the delegated UI, then you are definitely thinking about building up an interactive scenario if you need this. And so this is an option in our OSLC adapter. But OpenPDM comes with the notion of being a background tool synchronizing systems. And in that case, delegated UI is not the way to go in the first run. So we support both approaches, and not quite sure if I've answered the question.
Okay, I'm not sure I quite understand the question myself. I think that's it for the questions. Thank you, Lutz. Best of luck in ProStep. I think this is really good contribution to integration. Well, that concludes our second day of the OSLC Fest conference. I'd like to give a very warm thanks to all of the speakers, and also thank all of you viewers for your participation, for following us live for this 2.5 hours or so, and for your questions. I would invite you to join us again on day 3. You can see an overview of day 3 talks on the OSLC Fest website, but we'll be covering Prolog OSLC SDK, the role of OSLC in enterprise PLM landscape, enhancing end-to-end collaboration, hypermedia, Capella integration with the IBM Jazz.net applications, and an overview of the solid ecosystem. These are all things I'm particularly interested in myself. We'll also, one more, we'll be looking at Persistent Unite and the state of art of OSLC integrations. I would also invite you to check back on the links in the description field of the OSLC website and the OSLC forum and Slack channel for day 3 activities, and hope to see you tomorrow. Thanks for joining. Have a good day.